My talk is on machine-to-machine crypto economy, where we envision a future in which IoT devices not only share data, but also make payments. For instance, consider your vehicle paying for parking or your smart meter paying the utility bill without any intervention from you. To enable these micropayments, cryptocurrencies such as Bitcoin can be an attractive option. However, it's a challenge to bring cryptocurrencies to resource-constrained IoT devices. In this talk, I will talk about the realization of this vision and how to handle some of its challenges.
Welcome to talk.cybercni.fr.
Bienvenue.
So, welcome to the workshop Manage IoT at NOMS 2023, where we are currently with the event, so we are live on site. And also welcome to the 31st edition of the Talk CyberCNI Speaker Series, your monthly speaker series to raise awareness about cyber security. Today we have a very interesting topic. You probably read the abstract already. It's about enabling machine-to-machine crypto economy. And I'm already looking forward to the talk because it sounds very interesting. And for the talk we have today Kemal Akkay from the Florida International University in Miami. And as usual, we also have the second screen. So even in the room, if you want, you can use the second screen, which is that one. So I will change it because it's not correctly set up. So Alex, if you hear it, maybe you can change it because the ID is totally wrong. So it should be talk 31. But the code should still already work. If not, you can go to the Slido and then you can go. You can enter the talk 31, and this will be then the right URL. So the Slido, you probably know the tool, so there you can ask questions, you can upvote and download questions, and therefore it's always a good idea to follow it, because then you see the discussion that is ongoing. And obviously here in the room you can also ask your questions directly. So, for today's talk we have Kemal Akkay, and let's just jump back. So Kemal is a full professor in the Department of Electrical and Computer Engineering with a joint courtesy appointment in the School of Computer and Information Sciences at Florida International University. He received his PhD in computer science from University of Maryland, Baltimore County in 2005 and joined the Department of Computer Science at Southern Illinois University as an assistant professor. Dr. Akkaya was an associate professor at FIU from 2011 to 2014. Dr. Akkaya leads the Advanced Wireless and Security Lab at WISE at the ECE department. His current research interests include security and privacy, Internet of Things, and cyber-physical systems. He is the editor-in-chief of Springer Computer Science Journal, area editor of Elsevier Ad Hoc Network and Computer Network Journal, and serves on the editorial board of IEEE Communication Surveys and Tutorials. Dr. Akkaya was the general chair of IEEE LCN 2018 and also of the NOMS 2023 and the TPC of the IEEE ICC Smart Grid Communications. Dr. Akkaya was listed among the top 2% scientists in the world according to a Stanford University study in 2019. He also received FIU Faculty Senate Excellence in Research Award and FIU College of Engineering and Computing Research Award, both in 2020. Dr. Akkaya is also a fellow of IEEE. And with that said, Kemal, it's a pleasure welcoming you, and I would directly hand over to you for the talk. So we just have to check with the sound. So just stay for a second. Okay. Okay. Good. So now it should be fine. Yeah, perfect.
Okay, good morning again. Hopefully this time works. So thanks for attending my talk. I'll be talking about machine-to-machine economy using cryptocurrencies. So I do research on IoT for more than 2 decades now. And I witnessed the process through these 20 years, starting with the research of tiny sensors. And now we are all familiar with the term IoT. It was not there before. We were calling it, sensors or wireless sensor networks. And for those who may not have heard, IoT devices, those are, tiny devices that have capabilities to do computation, communication, and sensing. So we added this capability of sensing, different from the computers. And then we started to see a lot of research, commercialization, products. So if you go to Home Depot today, you will see a lot of smart home devices like smart thermostats, smart camera systems, and we have tons of different IoT devices available on the market today. Even our smartwatches or smart appliances, you see sample here, and we know that there are billions of devices already deployed. So according to Gartner, last year was 6 billion, and I'm sure it's increasing in different domains. So we are seeing them in major applications like transportation, homes, health, agriculture, energy, smart city, etc. So they're already here and now. So this means, we did a lot of research. We were successful in commercializing most of those ideas, and we passed through stages. Uh, so if you look at the research aspects of IoT in the last 20 years, there were a lot of research completed. And I just want to summarize, and I want to show you where we came from and where we should go, or where we can go. So if you look at the IoT device components here in this figure, there is obviously a primitive CPU with memory, but we also have a sensing unit, sensors, multiple sensors, radio, and connections with cloud, battery, etc. And over the years, we developed almost a standard stack where you see these IoT sensors at the first layer, called, some people call it perception layer, and then there's an infrastructure that supports the communication of these devices, the sensing data mainly at the network layer, and then there's this application layer on the cloud where you store the data and analyze the data. So this has been used by many people, and within this IoT device and this protocol stack, we did a lot of research, especially in early years, a lot of stuff on hardware-related research where we focus on doing energy efficiency in terms of those hardware, and then a lot of research on wireless communication related research for IoT devices, because they were mainly using wireless communication. And of course, security came later. We had a lot of security and software-related research on the cloud, and data analytics research, analyzing the data. So mainly we covered a lot of stuff, and still it's ongoing. But I can say that it reached a level of maturity. So perhaps the next question is, okay, where do we go from here? Are we done? We are successful. We brought these IoT devices to our lives. So what is next, right? As I mentioned, most of the fundamental problems are already studied. And as a researcher, I get this question a lot from students that, okay, what are the hot topics in IoT research now? What kind of dissertation topic I can explore? And it's a tough question now because, as I said, it's very saturated, and we covered most of the stuff. So some of the ideas that come to my mind, and I tell students, is perhaps there are a number of things that we can do next. One of them is still the IoT devices are not reachable to masses, or maybe you call it laymen. Uh, we have the devices there, right? But mostly, technical people can use them, can understand them. Uh, so perhaps there's a need for another push to bring these devices to laymen, so that without even understanding, their details, they can use them in various applications, in health, in agriculture, transportation, perhaps. This may require some maybe human computer interaction related research on how we communicate with those IoT devices. Um, how can we come up with nice user interfaces to attract those people? The other thing is obviously AI, and this is happening. So we can empower IoT devices with AI and machine learning so that they would have some sort of autonomy. Uh, they do their own decisions, and getting into that agency stuff, of course, a whole topic, a big topic, not just for IoT devices. The challenge there is, you have restricted resources, and how can you design approaches for IoT? That's already on the way. A lot of people are already studying that. And the other thing that I see as a potential is introducing financial capabilities to these IoT devices. So remember, when we started this research, it was mainly motivated by sensing. You sense the environment. And then they use these devices for actuation in some cyber physical systems. But it was mainly sensing data. So it was all about data. You collect data. You don't actually care about IoT devices ID, identification, right? But now we're at a level where these devices are everywhere, and they communicate with each other. They communicate with us. So uh, could we enable them to make payments, monetary payments, send and receive monetary payments? So that is where we have this vision, this future vision, machine-to-machine economy. And it's, of course, very much related to IoT, because we are talking about transactions between machine to machines, not just from a human to a machine, or machine to human. There are a number of applications that we can see here, but of course, this is just the beginning. So you may have cases where the IoT devices would like to offer their services. What services? They're doing sensing, right? So you have a sensor over there. You want to use that data, but that IoT device is not yours, right? They want to use that sensing data, and you know, they will charge for it, right? So you need that data, and they will send it to you, and you pay for it. Uh, so this might be a third-party service, just an example, or
the devices might need to exchange data for their applications, and that probably will not be free. Right now, it's free, perhaps because of agreements. But in the future, when we have a lot of applications, a lot of IoT devices, we may see different examples. So these are the examples that I can think that's already happening. Perhaps, for instance, the best example is these toll payments with the cars. So your car is, you're driving, and there's a lot of tolls in Florida as well, right? And you already have these RFID tags, and we pay automatically, but of course you need to set it up through your credit cards, or it may be an onboard unit. The cars have onboard units, and they can pay from there, or it may be an autonomous vehicle. This is also happening. That, like, consider a truck, for instance. It's doing transportation, uh, from one end of country to the other, and on the way it may need to interact and pay for gas, for parking, for tolls, etc. Also, we have seen examples in smart tourism, like they give you these bracelets if you go to these theme parks, and you can use them to get to get services, right? And that can also be used for payments. And actually, there were papers about this. They produce products, or probably proof of concepts, on bracelets and drinks to make payments, digital payments. Another example would be energy trading. You charge your electric vehicle, and it may pay for itself. As I mentioned, sensor data, the data selling. You can exchange data, get data from cameras, from drones, or even your smartwatch, your smartphone. You can make payments. This would be maybe from a device to an individual, but that's okay. So you can still enable payments capability on IoT devices. So there may be other examples coming up. So when you put all of these together at scale, this can create a machine-to-machine economy, and it may introduce new interesting research problems. So, of course, the first discussion here is what type of money we can use here to do transactions, right? I mean, right now we're using credit cards. When you set it up, or your bank account automatically make payments. So there are a lot of options. So credit card, bank card, obvious, and there are now digital cash, which are coming from central banks. These are ongoing projects in the US. Also, there is one, and of course, cryptocurrencies or virtual currencies. So we are familiar with virtual currencies in, like, if you're playing a game, they give you a virtual currency so you can spend it in the game, right? And cryptocurrencies are another story, big story, like Bitcoin. They are already in our lives, right? So these are the options that we can use uh, to do transactions. And of course, they come with different architectures. That some of them are centralized, some of them are distributed. So if it's controlled by a bank or a government, it's probably centralized. If there's no control, then you can um, use cryptocurrency or virtual currency. So that's another flexibility here that we can choose from. I'm not advocating any of these, but I'm saying that these can be used, and it can change depending on the needs. So obviously, security is a big problem here when you're sending transactions through IoT devices. You need to make sure that the transactions are secure. You need to make sure that they can be implemented on IoT devices. There are costs associated with it. Um, Single point of failure is a well-known problem in centralized systems. Privacy, anonymity, when you make transactions that can be tracked by others, that raises issues. And of course, usability, convenience. So how can you use those systems with different IoT devices. So one of the critical issues here, if you're going to talk about at scale, is interoperability or universality, which means, wherever you go in the world, you should be able to make those transactions, right? If you use a central bank or a credit card, and you travel, might be an issue in terms of supporting interoperability. So probably using cryptocurrencies might be a better option because it's everywhere. There is a standard, and as long as you implement it, you can send and receive without any borders. Right, so that's I think one of the elements that will contribute to machine-to-machine economy. So if you consider this type of ecosystem, and if you want to build this, what would be the challenges, research challenges? There will be a lot of research challenges, different than the existing ones. So obviously, I mentioned security and reliability. Of course, when you make a transaction, make sure that it is received by the receiver. So probably this can be addressed by existing solutions, right? I mean, we have a lot of maturity in this field in terms of secure communications. So I would not expect a lot of new stuff there. One of the new things that will come into picture is probably going to be accountability or provenance. So when you make a transaction, it will have a potential legal, tax, and other related issues coming with it, right? So you want to make sure that you can prove, you can go back, track, prove that there was a transaction, and you can held accountable the device which sent or received the transaction, right? So this adds a new dimension to the communication protocols because we never thought about these when we were using IoT devices for exchanging data, right? So this might be new. And another thing that would be needed here is a legally binding agreement or contract support among the devices. So you have a service and the other party will pay for it. So you need to have an agreement, right? And this sounds like smart contract concept in blockchain. I'm not sure if you've heard about it. This is already also happening. They can use smart contracts to build such systems. So probably, there may be some engineering research challenges there, but not really a lot of new stuff. And another interesting issue that I see here is the addressing of IoT devices. So we need, since we're doing transactions, we need to make sure that these IoT devices are uniquely identifiable because you're sending money to that device, right? But if you consider the IoT device or sensor network research, remember, we were all interested in data, right? We didn't really care where this, which device is supplying this data. And even we had this concept called named data networking, right? So you ask for data and you query, and the sensors will send the data. You don't really care where they are coming from because you're interested in the data, right? As long as you know the location, perhaps. But now here, you need to make sure that you know your sender, the receiver. So we need to probably rethink the data-centric approach for IoT. And this will take us back to regular computer networks where we have MAC addresses, IP addresses. But we'll probably need more than that in order to enable this type of communication. So all these things are telling us that we probably need to build a new infrastructure to support this type of ecosystem. And we see that most of the features that we discuss probably can be addressed by using blockchain services like accountability, addressability, security, interoperability. decentralization, scalability, perhaps. So if we bring blockchain, it will also come with cryptocurrencies. So it looks like blockchain and cryptocurrencies should have a major role here. But that's still not enough. Probably we need to have some sort of protocols and build an overlay payment network so that we can have reliable services. We can have searching for services. So let's say you're looking for certain services, certain data. How do you search? Right? Which sensor, which IoT device is providing this service? Or the other, if you look at it from the other perspective, how do you announce your services? Like it's marketing, right? And you need to have agreement protocol. So these will require creation of new application layer protocols, which can interact with blockchain. But we should keep the physical and MAC layer separate. So we can use any MAC layer of for IoT devices like Wi-Fi, LTE, 5G, Zigbee, LoRa, Bluetooth, etc. So up to here, I talk about this vision and try to show you that this might be a potential area with new and interesting problems. And we started to investigate some of the aspects in our own research group, did some initial work. So I want to talk about that if we have time. So what we did was something with Bitcoin. So before I start explaining why we chose Bitcoin, I want to tell you about cryptocurrencies if you're not familiar already. So you may know that there are a lot of cryptocurrencies after Bitcoin was introduced in 2009 with this blockchain concept, right? We've seen a lot of other blockchains and new cryptocurrencies coming with them, like Ethereum, Zcash, Litecoin. I think there are more than 6,000 now, right? And they are actually part of our lives. A lot of people are using them, but we see that Bitcoin has the largest market cap, probably more than 50% of the transactions with cryptocurrencies are through Bitcoin. And you can find a lot of places accepting Bitcoin. I mean, there were these YouTube videos that people are showing that can you survive, can you pay for your everyday needs with Bitcoin? And the guy was going to find a pizza place to pay with Bitcoin, or Uber accepting Bitcoin, etc. So it's already happening. But the issue with Bitcoin, as you may know, that it's very slow. The validation time for single transactions may take sometimes hours, and there are a lot of transaction fees. So you cannot really wait and use Bitcoin for real-time transactions because in IoT ecosystem, that the machine-to-machine economy, probably will do a lot of micropayments, just not big amounts, but really small amounts, and that means you need to have a real-time transaction support and maybe very, very little fees. The Lightning Network is an answer to these two problems. Bitcoin was slow, so they came up with a payment channel network. So that's a whole different world. But for Bitcoin, there's something called Lightning Network. For Ethereum, I think there's another one. The idea here is to move some of the transactions to off-chain, not writing everything on-chain. And this way, you'll speed up the transaction validation time, and the fees are very, very marginal. So it has been there for a while, probably 6-7 years, and there is a lot of people already part of it. It's like a social network, but it's now called a second layer on top of Bitcoin. So Bitcoin is the first layer, and you can use Lightning Network on top of it. So because of the promising features of Lightning Network, this is how things work. I would not go into details, but as I said, you can open channels with somebody else still things are recorded on blockchain, but when you do transactions, those are between you. And when you end that business at the end, you can make the calculations and write everything back to blockchain. So in between here, these transactions would not be written. So that gives us the advantage of making them much faster. And that's basically how Lightning Network works. But of course, there's a lot of details here, a lot of standards. So given these payment channel networks, it might be an attractive option to use Lightning Network to make micropayments in this machine-to-machine economy. So when IoT devices make transactions, they can use Bitcoin through Lightning Network, and we can realize this vision that I was talking about. But even that comes with some challenges, because when we wanted to run a Lightning Network with IoT devices, we realized that still the resources are not enough, because you need to install that Lightning Network, Bitcoin, and there's a huge storage requirement there. Of course, there are computational capabilities in terms of the cryptography behind those transactions. So we decided to explore how we can realize these Lightning Network transactions with IoT devices without requiring these storage and computational capabilities. So we came up with a lightweight payment solution. I'm going to talk about it briefly without getting into a lot of details. So the main idea here is to introduce a gateway, a third-party gateway, which can provide these services. It can be untrusted, and we can use the gateway and make transactions through that gateway as the IoT devices. So the IoT devices does not have the resources, but the gateway can run the Lightning Network and Bitcoin nodes, and you can communicate with the gateway, and you can make the payment. So it's like a proxy, but we cannot trust the gateway. So for that part, we decided to use multi-party computation, threshold cryptography, that I will mention, but this is the setup that we had. Any IoT device with any MAC layer can communicate with a gateway and can talk to another IoT device. This blue part is the Lightning Network, and they can install Lightning Network software, and they can communicate. So the threshold cryptography is well known because this is part of multi-party computation. Basically, it's distributed signing process, and the private key is divided into multiple pieces and shared among the participants, and then they sign together. So in our example, we have the gateway, we have the IoT device. They use threshold cryptography to generate a key, and then using that key, they use, again, collaboratively sign the transactions. So both IoT and the gateway contribute to that signing process. And there are different examples that we can use. I mean, the threshold cryptography domain is a whole different domain, and there are many examples that you can choose. So we chose this threshold cryptography example, the two-party ECDSA, available. It's lightweight, and it can do key generation, signing, and the IoT device and gateway uses this process to create a channel between each other. And for that, the only thing that IoT device needs to run is a threshold client, and the server will be running on the gateway. So that threshold client, we'll see in the experiments, that does not require a lot of computation. And as I mentioned, here we don't trust the gateway because the money is involved here, right? And we also assume that the gateway can collude with other elements, other parties that you see here. There is a bridge LN node that the gateway creates a channel with, and through that channel, it has access to the Lightning Network. So they can talk to each other, they can collude, and the gateway can broadcast all states to the blockchain. If you look at how blockchain and Lightning Network works, you keep these states of your funds, right? So if you broadcast the old state, you're trying to cheat basically and steal the money of the IoT device. So
Don't take some of the risk.
what is it?
I mean, does the LN provide float and the blockchain settles?
LN provide what? Float?
The float, and because you don't, it's not really credit because it's not trusted, and you don't know if the transaction is going to settle.
Yeah. So the transaction initially there's a wallet that the gateway receives the money. They create a channel. When they create a channel, they sign the transactions together. And then once the channel is available, then again by signing they send the transaction. So if LN tries to send transactions, tries to cheat, that will not be accepted by the
So it
blockchain.
could only go up to whatever credit is provided to it.
Yeah, yeah.
And after that, it depends.
Will not be able to use it. And we assume that we can secure the communication between IoT device and gateway because that's where our protocol is coming. It's not difficult to do that with like TLS type of connection. And what we did is changing these three operations. Basically, when you want to use LN, you need to open a channel with somebody, and you need to send and receive payments through that channel, and finally close the channel. So there are three operations, and these are all defined by the specification of LN protocols called Bolt. So these are just background information. If you go check the Lightning Network specifications, there's a lot of details on how they create the channels, how they close the channels. I mean, the messages exchange between funder and fundee. But since these three are related to us, we propose to change, or we propose to work with those in our protocol for the IoT device. And this paper was published at ACM WISEC. So I'm going to just show you basic ideas and some results. So as I said, first, we looked at the channel opening process. How can an IoT device open a channel with the gateway so that it can be used together? So the red part here is coming from the specifications to open a channel. The green ones are introduced by us for creating the key and signing the transactions to create this channel. So as you can see, at different steps, we are requiring the gateway to talk to the IoT device. And like, for instance, if you want to sign, the gateway cannot sign it. It needs to sign it with the IoT device by doing this threshold cryptography. And once the channel is opened, it's a channel shared by the gateway and IoT device together. But of course, the gateway is operating it. For creating this process, we thought that we can incentivize the gateway. So the gateway, I mean, why would you serve, right, the IoT devices? So potentially one solution is you can act like a third party and can say, hey, I'm providing these services. I charge for each transaction, or I charge monthly, whatever. So for each transaction, you can charge a fee when it's passing through the gateway. And in order to do that, you need to change the transactions of the standard, introducing another output. So this was the only addition we introduced for that standard, so that the gateway can charge and get the fees. Otherwise, if you don't trust the gateway and if you don't provide any incentives, this won't work.
IoT device is responsible for normal operation, like doing other things than just payments. So will that be one gateway that takes care of the regular operation? And
Yeah, it may be different. This is just for payment operations. I mean, there may be other gateways for sending data.
at a given time, an IoT device can connect to multiple gateways.
Yeah, as I said, these gateways are like third-party services available. And you're looking for somebody to make payments on behalf of you. So you can work with any gateway. You can work with multiple gateways as well, depending on the application. We're thinking about the toll payments, for instance. So if you have an onboard unit and you want to pay for the toll with your vehicle, so we'll talk to the gateway and it's available. So you work with it and you make the payment. So the other thing that we change is the transaction itself. Again, this is how LN sends the transactions. And again, we require threshold signing added to the protocol. And this is happening between the IoT device and LN gateway. And all these communications are secured. And finally, you can close the channel. There are different ways of closing in LN. You can mutually close or you can unilaterally close. Again, when closing, you need to have this threshold signature available from the IoT device. We did some security analysis as well. So there was a lot of discussion on, if there's collusion between gateway and the bridge device. How do you make sure that this doesn't happen? So we did a game theory-based analysis to show that closing the channel normally would be the optimal state or equilibrium. Otherwise, there's no incentives, there's no payoffs for IoT, for bridge and gateway. So I'm going to show you finally some results here. We implemented this on a Raspberry Pi device, and there's a gateway on the cloud. And we took this C Lightning. So there are different implementations of LN. One of them is C Lightning, and it's public. Their code is publicly available. So we got that code, and we modified the code to add this threshold cryptography capabilities. And then we had the IoT devices talking to the gateway sitting on the cloud, basically in a computer. And we installed the threshold client and server. We installed Bitcoin node on the computer. And we used both Wi-Fi and Bluetooth, BLE, to test both that communication between IoT device and the computer. Here are some results. I mean, we have more in the paper, but just wanted to see what is the overhead in terms of computational delay on a Raspberry Pi. So the key generation, signing, these may take time, but we found out that they're really not taking much time. For instance, signing is 166 millisecond. The key generation takes more time, but it's just one time when you open the channel. Because once you open the channel, you can use it for many transactions as long as it's not closed. And the other thing is the communication delay between the IoT device and the gateway, right? So it will introduce additional communication delay. And we looked at the communication between coming from the MPC, the threshold cryptography. So we compare it with the case where, let's say, we don't have an IoT device. We're making the payment from the gateway to the destination directly, right? There's no IoT case. And our cases are, there's a Raspberry Pi, it uses Wi-Fi and Bluetooth, and we compared sending the payment and receiving the payment from the destination, and also opening and closing time for channel. So channel opening and closing is, as I said, just once, at the beginning, at the end. and you can do this in advance. And they're, of course, taking more time compared to no IoT case, but still it's reasonable. And as I said, since this can be done in advance, that's okay. The interesting results are here. You see, if you use threshold cryptography to send the payment with Wi-Fi versus no IoT case. So of course there's a difference, but it's not a major difference. And with Bluetooth, it increases a little bit more. So we got really promising results, especially we thought that this can be applied, for instance, to a toll payment use case. So if you consider a car passing through the toll with certain speed and using Wi-Fi or Bluetooth, could we get this transaction done before the car leaves? I mean, before the car is out of range of the gateway. So for instance, consider Wi-Fi or Bluetooth, the range would be, let's say, from 100 meters to 300 meters, let's say, outside. And the car would probably be, slower, but let's assume that it's coming with 80 mile per hour. So using those numbers, you would probably have around 3 to 8 seconds of time to finish your transaction. And we show that here, you have 1 second and 297 for Bluetooth. So we're still within the limit with that speed. So it shows that it's feasible to use it. And of course, there's a cost analysis here. You need to pay the gateway. So charging a 5% fee. We looked at the fees of Lightning Network, and it came down, like, of course, these are assumptions. If these are based on the Florida numbers, if the toll is 75 cents per pass, and you use it 2 times per day, so you will have this $225 extra cost per month, which may be reasonable, considering the credit cards service charges.
So what is the difference between how it's used today? There's some transponder in the car.
Right.
So it immediately knows the identity of the car. The system.
Yeah, there is. I think there's an ID on the transponder.
Right.
So
So
it's
why would-
you had accounts.
So how is this different? The system is placed today from the user's perspective.
There is no credit card because you pay through the card. I mean, I pay through my credit card.
Yeah.
So there's an account online. I go there, I register my transponder, and then every month they charge my credit card.
How is this different?
This one, there's no credit card. It's just through the cryptocurrencies.
Oh,
Question just on the previous slide, because
Yes.
we're talking about, okay, so when you did this evaluation, what was the load? So there's the communication delay, but there's also the load on the, so.
Right. Good question. So we use this, Bitcoin has Lightning Network has a test net. So you can test there. It's actual network, but it has users on it. So it's not empty, right? There is already a load there. But of course, in real life, they use mainnet. That's where you pay. We didn't want to pay. So if you really pay, you want to test this, you need to pay for it, right?
Yeah.
Testnet, you can create your, Bitcoin, and it's free, but there are still users on it. I think, I don't know the numbers, but thousands of users using it.
Okay, so because you were doing it on the Raspberry Pi, so you can, okay, all right.
No, Raspberry Pi, gateway communication, fine, right? It's the Wi-Fi, right? But after the gateway, we got into the Lightning Network environment where there are a lot of other transactions happening. So that is where we have people, as you said, that might impact our performance. Anyway, let me wrap up. Yeah, so as a conclusion, I think this is just an initial step to realize machine-to-machine crypto economy. There are, of course, several other issues that needs to be explored. We can start with identifying perhaps more use cases, understanding potential impact of legal issues, dispute resolution, business aspects of these transactions, IT service searching and agreement, perhaps new design, blockchain design for IoT. This is also a hot topic happening. We did it for Bitcoin. Of course, it can be done for Ethereum and other cryptocurrencies. The other thing that we are right now looking at is the offline payment. So if you don't have internet access, can you do it on the wireless mesh network using Lightning Network? So let's say you don't, in this case, they have access to internet, but if you don't have access to internet, can you still make Bitcoin payments? And we showed that it's possible to do that with Lightning Network in our current work. So it will probably require some interdisciplinary research collaboration because, as you see here, there are legal issues, business aspects, and that might bring interesting issues to the scene. So I'll stop here. Thank you so much. I'll be happy to answer any questions. So if you are interested, you can check our website and my personal website and get more information about the papers and this project. Thank you.
Thank you so much, Kemal, for the
Are
great
we on time?
keynote. We're perfectly on time. As we're online, it's always a little bit mess for the technology. I would switch the mic because I know already that otherwise we have double echo.
Should be.
You can remove the other. I will just mute it. So therefore, now the audio should be better. Just hide this. Okay, perfect. Alex, can you give us a sign if the audio is okay from the remote side? Okay, perfect. Good. Yeah, so great, great talk, and also super interesting topic that I was actually never thinking of before you sent me the abstract, so very nice.
Thank you.
Related to that, also my first question, you quickly talked about it, but I think it would be worth talking a little bit more about it. So what would be the motivation for doing this? So is it, we also have some questions in that direction. Is it sustainability? Is it like the devices are laying around anyways, therefore I want to do it? Is it I have something to trust? Is it engineering in the sense, okay, this is the hardest devices to put something on, so we did it and we found out that it would work. So what was driving you in doing this research?
I mean, for this Bitcoin
for using
payment?
the Bitcoin payments distributed on the smart meters, Raspberry Pis, you name it, on IoT devices.
So in general, the need for machine-to-machine economy, that's application specific, I think. So of course, that's also a choice, right? So you may want to use credit card payments as well. But some people I know, they would like to use cryptocurrencies because they think that it's more secure or, more privacy is there. The government cannot track it. So there are a lot of users out there who would like to use cryptocurrencies for transactions. And this might be a convenience for them, to use in their daily lives. I'm not saying that I'm not enforcing that, okay, we should use it. It's just a choice. It's there, it can be provided. But the question of using transactions, now it doesn't have to be cryptocurrency, it can be like digital cash, right? So if you have digital cash, can you enable this type of infrastructure? I think that's still valuable for future because we will have these autonomous devices and they will probably need to make decisions by themselves and payments. So I think this research it doesn't just apply to cryptocurrencies, it applies to any type of payments.
Mm-hmm. Very good, very good. Mm-hmm. So maybe, Alex, let's start with one remote question and I give the mic to Erkin for the questions in the room.
Thank you, Marco-Lisa. Thank you for the presentation.
This is probably due to the audio setup here. Give me 1 second.
Yeah.
because here is actually a speaker, but it seems not to work. So to speak again.
Okay, can you hear me now?
Yes. Yes.
Thank you, Mark Oliver, and thank you for the presentation. There are a few questions about the IoT and the crypto usages. So the first question will be, what is the advantage of using the IoT as a backbone? And the second one is, what about energy consumption and cost of using IoT for crypto?
So for the first question, the backbone is still the internet backbone. The IoT connection is like last mile. So you connect to a gateway that is already part of the internet, and after that it's just use the regular infrastructure. But if you're talking about infrastructure like an ad hoc mesh network, then yeah, this might be a valid question. And in that case, we need to come up with different solutions, because if you don't have access to servers and storage, this might be difficult to run. The second question about energy, we also had some measurements for energy consumption on the Raspberry Pi when you do these threshold signing. Of course, it's a lengthy process. I mean, it's slow and it's taking energy. But we found, I don't have the numbers, but we found that with AAA batteries, you can continue doing transactions for a couple years. So it's not bringing a huge consumption to IoT devices. Of course, it will depend on the IoT device. I mean, if you have a small IoT device, that might be a question. You may be limited to a certain number of transactions per day. It's a good question.
Thank you.
Okay, someone from the audience here?
Yes.
Quite an interesting talk. I had two separate questions. One, I did not see any involvement of network layer. So you were working at the Mac and Phi, and directly it will go to application layer in one of your architectures. So the role of IP and how that comes into play, is it even relevant here?
It's not relevant. I mean, as long as you have connection, like they say, use Wi-Fi, right, or Bluetooth, you connect to a gateway, and then the rest is just internet infrastructure.
Yeah, that's what I thought, that because of the use cases you're trying to address, it does not really matter there.
Yeah,
But
application layer and Mac layer is enough.
Yeah.
The rest is infrastructure. I mean, just our network infrastructure.
And the second question was the funding part. So, like, if I compare the examples, I still have my credit card with the transportation company and they charge me. In the case of cryptocurrency, there are two issues that arise. One, the value of the cryptocurrency itself as against the real dollars and all. How is that? How will that get taken care of here? And second part is, if I don't have the funds, and how will my channel react to it?
Yeah, you cannot make transactions. You need to put funds. It's like if your credit card is declined.
You get fined if I pass through the toll.
Yeah,
Later on you get fined.
right. We didn't think about it, but it's just no service at this point. Maybe it's a good point to to explore.
I guess the concern here is when your IoT device is not a standalone device, it is still bound to your license plates and some other pieces
In
of
our case,
information.
yes, but in the future, I'm thinking that if we have AI, like a robot, for instance, it may make its own decisions, right? So it may use the money there without asking you. I mean, you may not be aware of it. So there may be some future cases where they have more autonomy, the IoT devices, and use that money to make payments as needed without you getting involved. In these examples, you're probably setting it up. You know that it will be used for tolls, and you're okay with it, right? So you still have like a tacit approval there, but maybe there will be cases in the future where there's more autonomy with the devices, and they will need to act more independently. So as I said, this is evolving, and probably we should find out, analyze what might be example use cases in the future for that.
I have a short question. Have you ever thought about its also security? Because I think as the first step, now you try to make it work, and okay, now it's working, it's feasible. But the next step would be probably, will it be attacked? What are the risks? What damage can be caused?
That was part of it, right? So we use threshold cryptography. It's secure, that you can sign it without any issue. Any messages between IoT device and the gateway is already encrypted. The security part after you're on the Lightning Network is already handled, right?
Yeah,
so
that's true.
that it has its own standards. But there are some attacks, like I mentioned, collusion. These nodes can collude, and we analyzed those in the paper. We showed that through game theory, the attacks may not make sense, and it will not bring any payoff.
Yeah.
But of course, there may be other attacks. I mean, we have not thought about a comprehensive threat model right now. Just focus on the obvious ones.
Yeah.
So it's still evolving.
Thank you.
Okay, Oscar.
Okay, perfect. One
Question there?
One more.
One more question. Okay.
In one of the slides, you mentioned that the channel is owned between the gateway and IoT devices. So is this a subset of the IoT devices or a big group of the IoT devices? So depending on the answer, is there any disruption to the approach if a number of these IoT devices become offline?
Yeah, I mean, in order to make a payment, you need to be online, right? So you talk to the gateway, and you can be offline. It will take care of the transaction. But if you want to, let's say there is a reimbursement that you need to receive. In that case, you need to be online, because you need to sign that transaction as well. So if you're offline, you will not be able to receive it.
Right,
So
but it doesn't involve other IoT devices, yours.
Yeah, just you.
Okay.
Yeah.
That was the question.
Okay, guys. So I think there's a really last question, a little bit an outlook question. So what would it take to get this deployed? So what are the inhibitors that we have today to have such a solution deployed? Obviously, there are some clear ones, like it's not, you cannot access the devices easily and so on. They don't have the software installed. But all this is solvable. But which are the hard inhibitors for having such a solution? Are there some, or would you say, okay, if a big telco provider or IoT provider will include it tomorrow in their distributions, it would be ready to run?
Yeah, I think there are many parameters, and these are not independent of, I think, blockchain deployments, because we are also facing similar issues when you want to use a blockchain. You need to deploy it. People should use it, right? Lightning Network, for instance, not everybody knows about it. So first, there are challenges with use of blockchain. Second, challenges with use of Bitcoin, right? I mean, it's not common. And third, when you want to deploy it, you want to make sure that every IoT device would have the same solution, like interoperability. Like they should support probably same threshold signing. So I think at this point it might be more like a very application specific. But in the future, as you grow and people see that it's working and try to deploy it, maybe it can become the vision, machine-to-machine economy.
Cool. So looking forward to follow that.
Okay.
So let's thank Kemal once again with a big applause.
Thank you. Thank you.
And for the people online and also those here, let me just switch to this. So in this series where we also broadcasted this right now, as I said, there's once a month a talk about cybersecurity. It's free, it's online, it's on LinkedIn, YouTube, and Facebook. And the next edition will already be on the 31st of May. And the next speaker will be Ludovic May, who is responsible for the research directions in the INRIA. And yeah, it will be on the 31st of May. And I invite us now to watch the outro. It's short, and then afterwards I will do the introduction with Filippo to the workshop, and then we go to the posters.
Cher cybercéanie, pôle d'excellence région Bretagne. Au revoir et à la prochaine.